the second routing protocol, that is OSPF. OSPF stands for Open Shortest Path First. O stands for Open Shortest Path First. Open Shortest Path First. OSPF is by far the most popular and important routing protocol in use today. OSPF have AD as 110.110. This is a L3 or layer 3 protocol that have 89 protocol number. This is protocol number. This is a link state routing protocol. Open Shortest Path First is an open standard routing protocol that's been implemented by a wide variety of network vendors including Cisco. Most popular opt for OSPF, which works by using the Dijkstra algorithm. This is the name of algorithm that is run behind OSPF. EIGRP's convergence time may be fast, but OSPF is not that far behind. Its quick convergence is another reason it's favorite. The another advantage of OSPF is it supports equal cost load balancing, and it also supports IPv6. Here are some OSPF best features. These features are: it allows for the creation of areas, minimize routing update traffic, it's highly flexible and versatile and scalable. It supports VLSM also. It also supports unlimited hop counts. It is open standard and supports multi-vendor deployment. Here, the OSPF and RIP version 1 and version 2 have some differences, that are OSPF and RIP. OSPF is link state routing protocol and RIP is distance vector. It uses multicasting and RIP uses broadcasting always. Sometime RIP version 2 uses periodic multicasting. The metric is depend on bandwidth in OSPF. But in RIP, the hop count is used for metric. Hop count limit is unlimited. We can use unlimited hop counts. And in RIP, the maximum limit of hop count is 15. Its convergence is very fast, and RIP have slow convergence. RIP have periodic updates, but OSPF have event triggered updates. It means when the changes occurs in topology, the update will send. But in RIP, updates will send every after 30 seconds whenever the change occurs in topology. That not matters. OSPF uses Dijkstra algo, and it uses RIP uses Bellman-Ford algorithm. The best thing in OSPF is it allows us to subdivide the large network into smaller subnetworks. For example, this is a larger network, or this is a whole network. We divide this network into some areas that are interconnected or interrelated. It is a really powerful feature that I recommended. Three of the biggest reason to implement OSPF is to decrease routing overhead. Second reason is speed up convergence. The third one is to confirm network instability to single area of network. Let's take an example for a better understanding of OSPF. Here we have some routers. For example, this is our first area, this is our second area, this is our third area. We have another area like this area is area 0, this is area 1, this is area 2, and this is area 3. In OSPF, area 0 is the most important area and it is called as backbone area. All other areas are directly mostly connected to backbone area. It means we do not connect any other area here. We need, if we want to connect an area, then we mostly use area 0. We cannot connect here the next area. In this scenario, the area 1 is directly connected to area 0, area 2 is also connected to area 0, and area 3 is also connected to area 0. So in OSPF, every other area must be connected to area 0. In CCNP, there are a different option we are having, that is virtual links. That is not part of CCNA course, so we will discuss about virtual links and how we can create virtual links. We will discuss about it in CCNP. The all routers that belongs to area 0 are called as backbone routers because area 0 is backbone area, so all routers belongs to area 0 is called as backbone area. And a router that belongs to different areas like R6, R3 and R2, these routers belongs to two different areas. For example, a router that one interface is a part of area 0 and this any other interface is part of the different area except area 0. So this router is called as ABR, area border router, ABR. And if we have another routing protocol, for example, in this scenario we have a router here and we have another routing protocol like RIP here. So this router that is a part of OSPF also, at the same time this router is part of another routing protocol. This router is called as ASBR, Autonomous System Boundary Router, ASBR. Now the scenario is like this. This is router 1. This is our area 0. Area 1. This is area 2. This is RIP. Here we are applying RIP protocol. So all other area except backbone area are directly connected to backbone area. These router are 2. Here we have another router. R1 and R2 are ABR because these routers, one interface is belong to area 0 and another interface is belong to another area. Like R1 having this interface in area 0 and this interface in area 1, and for R2 this interface and this interface are belongs to area 0 and this interface belongs to area 2. So we can say ABR is a router that connects area 0 to another area, that may be area 1, 2 or any other area. Area number is a 8-bit value in binary format, so we have area 0 to 255 maximum. This is the area limit. And now R2 is also connected with another routing protocol, that is RIP. So R2 is ASBR also. ASBR stands for Autonomous System Boundary Router and ABR stands for Area Boundary Routers. R1, R5 and R2 are backbone routers because it belongs to backbone area, that is area 0. In OSPF, within area, OSPF performs or act like link state routing protocols. It means within area, every router have whole topology information or whole network information. For example, R2 knows about R1 and R5. R5 also know about R1 and R2, and same R2 have information or topology about of R1 and R5. But between the area, OSPF act like distance vector. R1 is responsible for sending topology information between these two areas. So R1 sends information like distance vector. R1 does not send whole topology information in another area. So ABR performs a task, that is send information between areas, but when ABR sends the information between areas, it does not send whole topology information. It only sends the routing table.